Hello everyone, welcome back. So today we're going to start a new topic, that is AC analysis. So in order to understand AC analysis, first we have to understand what are AC circuits. And before understanding AC circuits, we should know what is AC. So AC stands for alternating current. As we know, it was discovered by Nikola Tesla and George Westinghouse. And how do we represent an AC signal? By a sinusoid, right? So AC is an alternating quantity. So if we consider this is with respect to voltage, then it has a maximum value of Vm, minimum value of minus Vm, and translating with respect to omega t, and these are pi and 2 pi readings, right? So the sinusoidal current is usually referred to as the alternating current AC, right? Such as the current reverses at regular time interval and has the alternating positive and negative values. The circuits driven by sinusoid current or the voltage sources are called as AC circuits. So how do we represent this? The AC is represented by, sorry about this, this should be omega. Okay, so how do we represent this? So it is represented by Vt equals to Vm sine of omega t. So where Vm is the amplitude of the sinusoid and omega is the angular frequency and the unit is radian per second, and omega t is the argument of the sinusoid, right? Now this Vt can also be written as Vm sine of 2 pi ft, where omega is represented by 2 pi f. As we already know, omega is given by 2 pi f. Now considering this, what we can write here is, if we bring this f on left hand side, then it will be omega divided by f equals to 2 pi. Then 1 by s we know it is given by t. So if we determine t, it will be given by 2 pi divided by omega, which is the period of the sinusoid, right? So now, in order to move any further, first we should know few terminologies. So let's start one by one. What are those? So to starting with, first one is waveform. So what is a waveform? So waveform is a graph in which the instantaneous value of any quantity is plotted against time, right? Then is cycle. You know, these are already known terminologies, but since we are discussing a circuit, so this discussing about them are also important. So what is a cycle? Cycle is a one complex set of positive and negative values of an alternating quantity is termed as cycle. So this signal from this point to this point constitute a cycle, right? Then next is frequency. What is frequency? The number of cycles per second of an alternating quantity is known as frequency, and we represent it by hertz. Next is time period. So what is the time period? So time period is the time taken by an alternating quantity to complete one cycle is called as the time period, and it is denoted by t, and we know t is given by 1 by f. Then next is amplitude. So amplitude is the maximum positive or negative value an alternating quantity So, the maximum value that we have in a alternating quantity and the minimum value. So these are let's the amplitude. Now coming back to the discussion, next is phase. So what is a phase? The phase of an alternating quantity is the time that has elapsed since the quantity has last passed through 0 point of reference. So in order to understand that, so let us see first what is a phase difference. So if this is an alternating quantity, suppose this is given by Im, and we are having another alternating quantity which is given suppose by Im2. Now as you can see, this is starting from this 0, but this Im2 is starting from this point, maybe somewhere after pi by 2. Let us consider for our convenience this is pi by 2. So this signal is starting at 0, this signal is starting at pi by 2. That means Im2 is starting after pi by 2. So the phase difference between them is pi by 2. So the phase is, what is the phase? The phase is the alternating quantity. The phase of alternating quantity is the time that has elapsed since the quantity has last passed through 0 point. That means from this point to this point. So it will consider a alternative phase. Now that can also be represented with respect to a phasor diagram, which can be seen like this. So this is the phasor diagram, and this is the alternate quantity when it is moving in, and this is the phasor. The line that we can see here is represented here is the phasor which is moving in anti-clockwise direction. So now in order to know about this, we'll again discuss this phasor diagram in our later discussion. So before that, for now, just understand that this alternating quantity can be represented by this phasor. So we'll see how it is or how it works. So we'll see it in our later discussions. So now moving on to our terminologies. So we have discussed about waveform, what is cycle, then frequency, time period, amplitude and phase. Right. So now next thing is root mean square. So you have definitely heard of this term known as RMS, which represents root mean square, right? So what is the root mean square? Root mean square is the effective value of an alternating current, and it is defined as that the value of CD current or direct current which will do same amount of work in same time or would produce the same heating effect as when the alternating current is applied for the same time. So that means RMS is the amount of CD, CD current that or direct current. That means RMS is a DC value. So that amount of current which will do same amount of work in same time which will be produced by a AC signal. Okay, so it is the equivalent DC equivalent of the AC signal. So now let's see how we represent this. So the root mean square value is given by I1 square plus I2 square up to IN. These are the instances of the current, and divided by the average, taking the average, and this is square root. Okay. So RMS value is determined by the taking the mean of the square of the instantaneous values of current over one complete cycle. Okay. So now if you want to represent this with respect to voltage, and we will determine the Vrms of a signal given by suppose V equals to Vm sin theta, where theta is moving in between 0 to 2 pi. That means this signal that we have already discussed, it is moving from 0 to 2 pi. The value is given by V equals to Vm sin theta. So this is V t and this is your omega t. Okay. Now what will be Vrms? So Vrms is the square root of the DC equivalent So if you want to integrate, if you integrate this whole sum, then we'll get the value of VRMS. So it will be given by 1 by 2 pi because our range is 2 pi. So we'll be integrating from 0 to 2 pi. Then V square theta d theta. So as per the definition of VRMS, so this will be our integration. So after solving this, we should get the value of VRMS. So let's see what would be the solution for this one. So this will be 1 by 2 pi. Then 0 to 2 pi. We already know what is V. So V is given by this. So in place of V square, we can provide it here as Vm square sin square theta d theta. Then Vm is a constant term, so we can take it out from the integration, and we cannot directly integrate sin square theta. So what we do, sin square theta will be converted into 1 minus cos 2 theta divided by 2 d theta. Now integrating, I have Vm square divided by 2 pi. Then after integration, we will get this to be pi. For 1 integration of 1 is pi. Then integration of cos 2 theta will be sin of 2 theta divided by 2. Then we have another 2, so 2 into 2 will be 4. Then this integration from 0 to 2 pi. So now putting the 2 pi and 0 term inside, so what we get here is this will be theta will be 2 pi divided by 2 minus for 0 it will be 0. Then again minus sine of 2 theta 2 pi, so that will become 0. Then 0 is sine 0 is also 0, so plus 0. Now what we have here, 2 gets cancelled, pi gets cancelled. So what left after solving it, we get Vm by root 2. So root 2 is also given by 0.707 Vm. So the RMS value is given by Vrms is given by 0.707 Vm. So I hope you have understood why we call Vrms equals to Vm by root 2 or 0.707 Vm. I hope you have understood the reason behind, or we have discussed the derivation for Vrms. Okay, so now similarly we can also go for the average value. So the average value will be given as instances of current, all instances up to in, divided by the total value, total number. So this is the average value. So if we go for determining average voltage, so this is same as we have discussed already. So this is the value of V. Now V average is given by integration of 2 pi 0 to 2 pi. Then we have V theta d theta. Now as you can see, the sinusoid has V theta has, for this positive and negative value, we are doing the same operation twice. So what we can do, instead of doing it for the whole 2 pi, we can also go for 0 to pi and multiply it by 2. So if we do that, then this will be 0 to pi, then 2 times of 2 pi, then V theta d theta. So this will be 1 by pi, and we have here 0 to pi, and this is Vm sin theta d theta. Now after doing the integration, so Vm is a constant term, so we can take it out. And after integration, this will be minus of cos theta 0 to pi, and the value will be cos pi minus it will be plus, then again it will be plus. So what we have here is Vm 2 times of Vm divided by pi, which is also given as 637 Vm. So the average value is given by this, right? So these are about what do we know about the VRMS value and the average value and their derivations, right? So we have seen different terminologies, what is AC signal, how AC signal is represented, and what are the components of an AC signal. All these things we have discussed. So next, let us consider other terminologies. So first one is crest or peak or amplitude factor. So what it is? It is given by peak factor. Peak factor is given by symbol Kp. It is given by maximum value by RMS value. That means it is a ratio of maximum value to the RMS value. Then next terminology is form factor. Form factor is given by Kf, and it is the ratio of V RMS divided by V average. So it is a ratio of V RMS by V average. So these are two new terminologies you should know, and it will be required for solving any type of numericals or wherever we have to determine the form factor and peak factor, right? So I hope it is understood. Now if you consider any numerical, for example, suppose an alternating current having a frequency of suppose 50 Hz. Okay, so we have a frequency of 50 Hz. Has a maximum value of current given as 100 ampere. That means I am equal to 100 ampere. Okay, then suppose we have to determine or calculate the value of current at 1 by 600 seconds. So this 1 by 600 seconds is your T. Okay, so if we have to determine the value of current, so we know R and I is given by Im sine of 2 pi ft, sine of omega t, omega is 2 pi f, and here we can put down the values. So 100 ampere sine 2 pi, frequency is 50 Hz, and time is 1 by 600. So after solving, we'll get the value as 50 ampere. Like this, we can solve various numerical or basic signals. Then another numerical containing your form factor and peak factor. Suppose a non-sinusoidal, the question is a non-sinusoidal signal voltage is having a form factor of 1.2. So form factor, we know it is given by Kf 1.2 and a peak factor of 1.5. So peak factor is 1.5. Okay. Now what you have to do is you have to determine the average value of the voltage is suppose 10 volts. So V average, this is also given 10 volts. Next what you have to calculate RMS value and maximum value. So for RMS value, so using the formula, what we can write, form factor is given by Kf is given by VRMS divided by V average. It is directly straightforward question. So Kf is 1.2 and this is VRMS divided by 10. So after solving, what we get, VRMS is 12 volts. Now next, We have to determine Vm, that is the maximum voltage. So for peak factor, Kp is given by Vm divided by Vr RMS. Now here we have Kp value given 1.5 and Vm value we have to determine, and RMS value we have obtained here to be 12 volts. So the value of maximum voltage is 18 volts. So this is how we can solve various numericals. Now another type of numerical which you may encounter, that means suppose you have a signal like this. Instead of having full sinusoidal signal, so what we are having is we are having signal up to this point, then we are having a straight line, then this is the signal, then suppose it continues like this, or let us consider, let's repeat it from this point. Instead of going down, let's repeat the signal. So that means we will go here, again it will be constant, and then again it will be coming down. So this is 0, this is pi, this is 2 pi. So you have to determine what is the value of Vrms here. So now what we are having here is, now the signal is not a sinusoid, right? So how to determine the Vrms in this case? So in this case, earlier what we used to do, we used to write it like this: V equals to Vm sin theta or sin omega t, right? So now this V will be changed into another format. Suppose this value is pi by 4 and this is 3 pi by 4. Now what we are going to write here? So initially the value is Vm sin theta, where theta is in between 0 to pi by 4. Okay, then there will be definitely a value for this one. Suppose this is Vm by 2 or Vm by root 2. Just consider Vm by root 2, suppose. So the value is Vm by root 2 for the value of theta in between pi by 4 to 3 pi by 4, and then finally it is again Vm sin theta for the rest of the region, that is your 3 pi by 4 to pi. Now this thing will repeat for the next cycle. So if we have to determine the Vrms value, so now our Vrms will be, now it is just repetition, so instead of doing 1 by 2 pi, we can directly do it 0 to pi, and this is your V square theta d theta. Now here we break the integration between different ranges like we do in our normal integration numerical. Plus next will be, sorry, pi by 4 to 3 pi by 4. Okay, then last one will be 3 pi by 4 to pi. Okay, then we have here v square theta d theta in all the terms. Now in this, what we are going to put here is, in this v theta we will be putting this value, in this v theta we will be putting this value, and in this v theta we will be putting this value, and then solve. After solving, we'll get the answer. So it is as simple as that. So the thing is, we have to first determine the expression for v. That means what v represents for different instances of time. Okay. So I hope it is understood. and you will be able to recall your ideas on alternating quantities or alternating current. And we have seen today about what are VRMS, what is V average, and why we call it Vm by root 2. We have seen that derivation, and then we have also gone through the V average, and we have seen few numericals. So that will be all for today. So thank you for joining. We'll see you soon in the next class.